This video is going to focus on what happens when solar radiation enters our atmosphere and the different paths that radiation can take. Solar radiation is both the light and the heat coming from the sun. And as we get the solar radiation entering our atmosphere, three possible things are going to happen. The first is that it's just going to simply transmit or move through our air. That energy is not going to be disrupted. But the second thing that can possibly happen is that some of the energy is going to be absorbed from the air when it's moving through it. And then finally, we're going to see that some energy is going to be able to kind of bounce off these different gas molecules or some of those aerosols and move in a slightly different pattern. So depending on how the solar radiation is moving, if it's simply moving through, some of it's being absorbed, or it's bouncing off and moving in a different direction, we're going to have different processes occur. We can have something called reflection. And just like we would see light reflecting or bouncing off a mirror, with reflection, we're going to have that solar radiation bouncing off a surface at the same angle that it came in on. So clouds are really good at causing some of the reflection of solar radiation. When sunlight hits the clouds, it's going to bounce off and go back out into space. But the amount of radiation that's reflected is going to depend on something that's called albedo. And albedo is the amount of radiation that's reflected off of a surface. And we see that light-colored objects have a higher albedo or reflect more light than darker-colored objects do. So for this, think about this example. You have to do some kind of yard work on a July afternoon, and you have the option of either wearing a white t-shirt or a black t-shirt. You're probably going to choose that white t-shirt knowing you're going to be out in the sun, because the white t-shirt is going to reflect more of the sunlight off your shoulders, keeping you a little bit cooler. If you wore the black colored t-shirt, it would absorb the solar radiation and make your body a little bit warmer. Our Earth does the same thing. When we have light colored objects like clouds, it's going to reflect that radiation back into space. But when we have dark colored material like asphalt, it's going to be able to absorb that radiation and heat up. But the third thing that we can see radiation doing is when it starts to bounce off of other materials. And this is called scattering. We see that it causes the light to move in a different direction and it diffuses the light. It spreads it out over a greater distance. Most of the radiation from the sun does not reach Earth's surface. But when it does, we're going to see that the energy of the radiation is going to change. When the radiation is coming from the sun towards the Earth, this is called short-wave radiation. It's very high energy radiation. But if it hits the surface of the Earth and Earth absorbs that heat and energy, Earth is going to release what's called terrestrial radiation. This is a longer wavelength form of radiation, where the Earth is releasing lower energy heat. So a lot of this terrestrial radiation is caused by greenhouse gases. Gases like carbon dioxide and water vapor that are absorbing this radiation, and it heats up Earth's lower atmosphere, in the troposphere where we live. So we see this as the greenhouse gas effect. If you've ever been trapped in a car when someone's, let's say, getting a tank full of gas and they don't roll down the windows, in just the 3 or 4 minutes it takes to fill up a car, it's going to get really hot in that car. And this is due to the greenhouse gas effect. Sunlight is entering the car through the windows, but it's also preventing the heat from escaping the windows and cooling off the car. So in just those 3 or 4 minutes, the car is going to get incredibly hot due to the greenhouse effect, where it's absorbing that radiation and heat. The same thing is going on in our lower atmosphere. These greenhouse gases are absorbing all of that radiation and they're redirecting it back towards Earth's surface. So the more greenhouse gases we have in our atmosphere, the more radiation they're going to absorb. And by absorbing that radiation, they're absorbing heat. It's going to cause the atmosphere to warm up, also known as climate change.